Good morning, everybody. Today we have to continue the explanation of chapter 6 about chemical equations. The objectives that we are going to explain them today are about reactants and products of a chemical reaction, how to write a word equation of a chemical reaction, and finally to verify Lavoisier's law. First, let's start by defining a chemical reaction. A chemical change is represented by a chemical reaction, where one or more substances called reactants react with each other to produce one or more new substances called products. So, the chemical substances used at the beginning of the chemical reaction are called reactants, while the new substances formed are called products. So in a chemical reaction, we have two important terms, reactants and products. The reactants are the chemical substances that undergo a chemical reaction, while the products are the new substances formed during a chemical reaction. Take this example. By mixing the following ingredients and baking them, you will get a chocolate cake. So, the ingredients used are called the reactants. The substances used to perform the chemical reaction are called the reactants, while the new substance formed is called the product. Chemical reaction can be represented by an equation called word equation. To write an equation of a chemical reaction, you should start by writing the name of the reactants. In the middle, you should put an arrow, and after the arrow, you should write the name of the obtained products. For example, iodine reacts with aluminum to produce aluminum iodide. So it's a reaction between iodine and aluminum. So iodine and aluminum are called the reactants, while the new substance formed, which is aluminum iodide, is called the product. So to write the word equation, start by writing the name of the reactants, aluminum plus iodine. We put an arrow. After this arrow, you should write the name of the product. Here we just have one product, which is aluminum iodide. Let's solve the following application. In a test tube, put a small amount of sugar and heat it on the Bunsen burner for a certain period of time. During the heating process, you will observe the formation of a black deposit as represented in the given figure, in addition to the formation of water droplets on the internal walls of the test tube. So what's the visible sign that indicates the presence of a chemical reaction? The visible sign here is the formation of a black deposit, which is the change in the color. The reactant here is sugar. We just have one reactant, since only sugar is used to perform this reaction. It's not mixed with any other substance. The products are carbon which is represented by the black deposit, and the second product is water. To write the word equation, you should write the reactant, which is sugar. In the middle, you should put an arrow. On this arrow, you have to mention the heat energy, since sugar is decomposed under the effect of heat to produce carbon and water. Note that the obtained products have different physical properties and chemical properties than the reactants. So the products have different properties from the reactants in any chemical reaction. Let's take another application. You have to mix two colorless solutions. The first colorless solution is called potassium iodide, and the second colorless solution is called lead nitrate, as represented in the first part of this figure. So both solutions are colorless. Upon mixing both solutions, you will observe the formation of a yellow precipitate, a yellow solid called lead iodide, in addition to the formation of potassium nitrate solution. So what's the evidence for this reaction? Here we have two evidences. First, the formation of a precipitate, a solid, and the change in the color, since we obtain a yellow precipitate. The reactants are the mixed substances potassium iodide and lead nitrate. The products are the new substances formed lead iodide, which is the yellow precipitate, and potassium nitrate. To write the word equation, you should write the reactants potassium iodide plus lead nitrate. It produces, you have to put an arrow here. After this arrow, write the name of the products lead iodide plus potassium nitrate. The last objective that we are going to explain it today is about the conservation of matter, the conservation of mass during a chemical reaction, by performing the following experiment. What you have to do is to fill a test tube with a limited amount of calcium chloride and to place this test tube in a flask. This flask contains a specific amount of sodium sulfate, but be careful not to mix both solutions as represented in the first part to the left of the given figure. What you have to do now is to record their mass, to record the mass of the test tube and the flask containing the two solutions. In the second step, now you have to invert the flask in such a way that you have to mix both solutions, the solution in the test tube, which is calcium chloride, and the second solution in the flask, which is sodium sulfate. Upon mixing both solutions, you will observe the formation of a white precipitate, which indicates that a chemical reaction takes place. And the obtained products are calcium sulfate, which is represented by the white precipitate, and the second product is sodium chloride. Now you have to record their mass again. So you have to record the mass after mixing both solutions, after performing the chemical reaction. The observation is that both records have the same value of mass. You will obtain the same value. So mass is conserved. What do you mean by mass is conserved? So the total mass of the reactants used at the beginning of the chemical reaction is equal to the total mass of the products, the new substances formed during the chemical reaction. The reactants here are calcium chloride and sodium sulfate, so their total mass will be equal to the total mass of the obtained products, calcium sulfate and sodium chloride. This conservation in mass is represented by a law called Lavoisier's law, which states that in a chemical reaction there is only transformation, matter is conserved. Finally, by referring to the given reaction in the performed experiment, according to Lavoisier's law, mass is conserved, which means that the total mass of the reactant is equal to the total mass of the product. So the mass of calcium chloride and sodium sulfate is equal to the total mass of calcium sulfate and sodium chloride.